Alright, so we're going to talk about the evolution of animals. Now remember, when we talk about animals, these are your eukaryotic organisms. And so, here's one of the theories that we believe came up with our trends. So we know that the endosymbiotic theory states that we have these prokaryotes, a large one ingested a smaller one, and we were able to come up with a multicellular organism because they started to co-evolve together. Now, usually we have to start at the bottom and work our way up. So let's talk about sponges. Sponges are considered the simplest of all animals. And so when we look at this, they are one of the oldest things that we see in the fossil record as far as these multicellular organisms. However, it doesn't have any organs. It doesn't have organ systems. It's made of simple cells and tissue. And so we know that major trends in animal evolution, the oldest fossil for animals is about 630 million years old, and by 500 million years ago, most modern phyla of animals had evolved. And so we do have some major events that took place, and that's what we're going to talk about first off with these. So we know that they had to have some type of common ancestor, and scientists think that cells from a protist colony became specialized to do different jobs. When they became specialized to do these different jobs, we're able to evolve into our first multicellular organism. Now remember, when we talk about this, it goes from cell to tissue, tissue to organ, organ to organ system. And so we need to make sure that we talk about that in that order, because then you have a complete developed organism. And without that, we wouldn't have that. So we know that we went from tissue to organ system. We came from an asymmetrical body type to a symmetrical body type. We went from just plain sensory organs to a brain with sensory organs. We have a fluid-filled body cavity, complex digestive system, and our body parts are segmented. Those are all big evolutionary advances in animals. So let's talk about our invertebrates. Our invertebrates are one of our first things that we saw evolve. With our invertebrates, we had a big move from water to land. Now remember, your invertebrates would be your insects, your arthropods. And so these are what you see with your segments. They're going to have that most complex diversity for us. They started this. Once we moved to land, we have now gone into a different plateau. We're no longer typically invertebrates, but we're going to see the first amphibian on there, and that's going to be part of our chordates. Now, chordates have what we call as a notochord. This is a rigid cord that runs the length of their body. The notochord provides a place for muscles to be anchored to. It also gives a counterbalance for animals. Animals with notochords are typically called chordates. We are part of this phyla Chordata. It's also known as a spinal cord in the more advanced species. And so the amphibians were the first ones to come on the land that had this, and they were part of the chordates in the chordate family. From chordates, because not all chordates have vertebrates, we do have some spineless fish, but then we go into vertebrates. Vertebrates evolved from our primitive chordates. They occurred about 550 million years ago. The earliest vertebrate was known as a jawless fish called a hagfish. Okay, so these hagfish look kind of like an eel, by the way. They're so disgusting. But these vertebrates evolved a backbone to replace the notochord after the embryonic state. Now, even at an embryonic state, us, when we have a little baby just developing in the womb, it still has a notochord. That notochord will then turn into a vertebrate or vertebrae. And so we also will evolve a cranium with this. Because you have a nice backbone to support it, you can make a skull, which will then protect or enclose the brain, which was a huge evolutionary advancement. So our early vertebrates evolved to become more complex. Around 365 million years ago, they finally made the transition from water to land. We have our first vertebrates on land, which were the amphibians. They evolved from a lobed fin fish. And from the amphibians, we were able to go to reptiles. And then we were able to go to birds and mammals. Now, we also had one other step when we talk about this. The amniotes are really important. The amphibians were the first animals to have true lungs and limbs and live on land. However, they had to return to the water to reproduce, which was kind of a setback because they can't stray too far away. Once we had a reptile evolve, they had to come up with something different so they could stay away from the water if they wanted to. And these amniotes were the first animals to produce eggs with an internal membrane. The membrane let gases, but not water, pass through. Therefore, the amniotic egg or the embryo can breathe and not dry out. Now, these amniotic eggs were the first eggs to be laid on land. And so the species of reptile were not able to have babies live birth, but they were able to have babies by laying hard eggs on the land. And so this was a huge evolutionary advancement for them. This amniotes, which are the egg layers, were evolved about 350 million years ago. Many of them looked like the animals that we can see today. However, some of them were a little bit, I don't know, they still kind of looked a little more like a crocodile or smaller amphibians. They weren't really large species. Don't think of the dinosaurs yet. They're really, really much smaller. Within a few million years, these amniotic groups were able to evolve to form our mammals and to form our reptiles, dinosaurs, and birds. Now, these are really important because without this step, the amniotes, we would not have mammals, these larger reptiles, birds, species of this. So that was a huge evolutionary step. So let's kind of sum this up. The earliest animals evolved from our colony protists, which was about 600 million years ago. Many important animal adaptations evolved in invertebrates, including tissue and brains. The first animal to live on land were invertebrates, again, insects. Amphibians were the first vertebrate to live on land. Amniotes were the first animals that could reproduce on land without having to return to the water. Huge evolutionary step. And so if it wasn't for these steps, we wouldn't be able to go through and see the progression of life. And so we can also see this in the fossil record as well. Now, Charles Darwin was able to kind of reshape how we think about some of this stuff, but he still followed these same processes where we had these same steps going through. Now, next week we're going to start reading a chapter from Charles Darwin's book, Origin of Species, called Natural Selection. We're just reading one chapter. If you really want to read the entire book, Origin of Species, please let me know. I do have 2 copies of that book that I would gladly share with you to read. Okay? Have a great day, guys.